Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is conic sections. This is an introductory video on this topic. So let us define what is a conic section. Now consider a line L and another line M with an angle alpha between them, and let us try to rotate this line M along the line L. So if we rotate this line and this will move like this, we will generate a conic like this. Two cones will be generated. So this is that line M, this is the line L. So this is the axis of the cone and this is how the cone is generated. This is the vertex of the cone. Now in this cone we take a plane shown in this blue color and we cut this cone perpendicular to this axis. So when we cut exactly when this plane is perpendicular to this axis and we cut it, we see a section like this which is a circle. So this section is a circle. Similarly, if we cut this cone by inclining the plane, we get an ellipse. And similarly, if we cut the plane is like this and this is the cone, we get a parabola. So that is why this ellipse, parabola, circle, they are all referred to as conic sections, because from the cone and a plane we can generate those sections. For example, where parabola is used, you see in an antenna for tracking spacecraft and rockets, we use this parabolic antenna. Now let us come to circles. Equation of a circle with center 0, 0 and a radius r is given by x square plus y square equal to r square. Let us consider center as 0, 0 and radius r 2 of length 2. We get equation of circle as x square plus y square equal to 2 square, which is 4. But center may not be always in the origin or 0, 0. Suppose center is at point with coordinate h comma k. Then the equation of circle is x minus h the whole square plus y minus k the whole square equal to r square. For example, if the center is located at coordinate 3, 3, 3 and 3. Here is the center of the circle with radius 2. Then its equation will be x minus 3 the whole square plus y minus 3 the whole square equal to 2 square, which is 4. Now let us understand what is a parabola. Parabola is the set of all points in a plane that are equidistant from a fixed line and a fixed point. What does it mean? So this is a parabola. Why it is a parabola? Because if we take any point here, say P1, P2, P3, then its distance from a fixed point and a fixed line is constant, that is P1F will be equal to P1B1. Similarly, if you take any point, say P2, then P2F will be equal to P2B2. Then what is this fixed point? It is called the focus of the parabola. And what is the fixed line? It is called the directrix. Now let us find the equation of a parabola. Let us take this x-axis, y-axis, and this red color is a parabola. It is opening towards the positive x-axis. The equation is given by y square equal to 4ax. Similarly, if this is opening on the negative x-axis like this, then its equation is y square equal to minus 4x. This is the equation of this parabola, red marked in red color. Similarly, if it is opening in the y-axis towards the positive y-axis, the equation of parabola is x square equal to 4y. Similarly, if parabola is opening on the negative y-axis, its equation is given by x square equal to minus 4ay. What is latus rectum of a parabola? Latus rectum of a parabola is a line segment perpendicular to the axis of the parabola through the focus and whose endpoints lie on the parabola. Let us try to understand. This red color is a parabola, F is the focus we have seen earlier. So through focus and perpendicular to this axis we draw lines marked in this green color. which touches the parabola at points L and L dash. Then the distance L dash is the latus rectum of a parabola, and its distance is, this distance is 4a. Let us define ellipse first. An ellipse is a set of all points in a plane, the sum of whose distance from two fixed points in the plane is a constant. So this is an ellipse. It has a center and two focus here, and this is the major axis. From this point to this point, this is called major axis, and from this point to this point it is minor axis, and from the center to vertex is semi-major axis, which is half of the major. This is major axis, so from center to here it will be semi-major axis, that is half of the major axis. So if we take any point on the ellipse, its distance on the two focus is always constant. So let us take this point. So this distance is d1, this is d2. So d1 plus d2 will always be constant. We can take any other point. Say we take this point. So then this distance will be d1 and this will be d2. So this distance will always remain constant. So this distance from the center to one vertex OP is given by A. So this is called semi-major axis. So what will be major axis from here to here? It will be 2A. Similarly, O to Q will be B. We have defined it as B. So this is called semi-minor axis of the ellipse. So from Q to Q, this point it will be 2B. That will be minor axis. So from origin to the focus, let distance be C. Then this distance QF2 will be square root of B square plus C square. And since this distance is C, P to F2 distance will be A minus C. Let us define eccentricity of an ellipse. The eccentricity of an ellipse is the ratio of the distance from the center of the ellipse to one of the foci and to one of the vertices of the ellipse. So it is given by, eccentricity is denoted by symbol E, and it is given by C by A. What is C? From the origin to the focus distance, and A is from O to P. So what is eccentricity for an ellipse? It will be value between 0 and 1. Now if this ellipse turns to become a circle, then this distance C will become 0, and as such eccentricity will be 0. So for a circle, eccentricity is 0. It doesn't have any eccentricity. And for an ellipse, it is given by CA, and this ratio varies from 0 to 1. 0 and 1 not included. So this is the equation of an ellipse. This is the distance A0, this is minus A0, this is 0 minus B, this is 0B coordinate. Center is 0, 0. The equation of ellipse is a square by a square plus y square by b square equal to 1. What is latus rectum of an ellipse? We have seen this definition for a parabola. So latus rectum of an ellipse is a line segment perpendicular to the major axis. So this is major axis, a line perpendicular to the major axis. Any of the focus and through end lie on the ellipse. So through this pink color line we have drawn, which is perpendicular to the major axis, and it is touching the ellipse at 2 points L3 and L4, L3 and L4, similarly L1 and L2, and this distance of the latus rectum is 2b square by a. This is the formula for computing this length of the latus rectum. We have defined parabola and ellipse. Now what is a hyperbola? So we have seen this was a cone, and we took a section and we took a plane and cut the cone. We got a section as circle. Similarly, if this plane was inclined, we got this section as an ellipse, and another way we got a parabola. Now if we cut in a unique way both the cones, here we have cut only one part of the cone. Now if we cut through both the cones, then we get a hyperbola. Let us try to understand this. So this was the cone, and we have cut the plane through both sides of the cone. We get this red color marked shaded region as the hyperbola. So hyperbola has got two parts, two red color parts. Now we'll analyze that. So these are the two parts. Together they constitute as hyperbola. So again, like previously, P is any point on the hyperbola, then its distance d1 and d2 is always constant. Mod of d1 minus d2 equal to constant. In ellipse, we have seen d1 plus d2 was constant. In hyperbola, d1 minus d2 mod is always a constant. Let us find eccentricity of a hyperbola. It is given by again C by A. This distance to focus, origin to focus is C, and origin to the end point or the vertex is A. So C by A. Now it is important to see that C is always greater than A. In an ellipse, C was always less than A. So eccentricity was always less than 1. In a hyperbola, C is always greater than A. So it is always greater than 1. For a hyperbola, eccentricity is always greater than 1. Now let us find the equation of a hyperbola. This is the two parts of a hyperbola. The equation is given by x square by a square minus y square by b square equal to 1. Friends, with this we conclude the introductory video on conic sections. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.